It's Groove and we're back with another Binary Ninja video. This time we're looking at a static single assignment with Binary Ninja, or SSA as it's more commonly called. So what is SSA, and why is it something you might be interested and want to use? So SSA allows us to define a variable only once, so it's essentially read-only. And in doing that, we can go back and look at where a variable was defined and also where it's used. And that is useful in looking at things like, vulnerability research and reverse engineering. So, can we control a particular, variable? So if you've got an argument coming in, do we actually control that? Can we do something nefarious if we wanted to? And as part of that, investigation journey or adventure, there's a concept of a phi node. So essentially, phi node is where you have multiple variables coming in from multiple nodes. So maybe take multiple pathways, or wrapped in other functions. And what we would do is, when we're saying, hey, we've got these particular versions of a variable, so be it r1 #1 or r2 #2 and the like, we might say that this, say, r1 #3 is made up of the version 1 and version 2 potentially, and we depict that with the phi node. So there's we go to our notebook, we have an example here. And then what else can we do with SSA? So SSA is part of compiler optimization, and it's used for things like constant propagation, or value range propagation, or value set analysis, dead code elimination, all those sorts of things. But what does that mean practically, and how do we use that in Binary Ninja? So if we basically already grabbed our binary, but if you want to go ahead and do this yourself, the instructions are there. But yeah, if we load in our Trivision binary, so Trivision is a vulnerable old webcam, so we're not shouldn't be using this, is basically what I'm trying to say. So if we use the medium level IL SSA, and we load up a particular function within this binary, we can go through, basically iterate over the instructions and pull out the SSA form for that. And within this, you can see we've got our various versions and our phi nodes as well. So that's nice, and a little cell to use. But what if we wanted to do something a bit more practical with this, and say, well, we've got a call to memcpy, and we want to see if the third parameter to memcpy is vulnerable. So does it take a negative, potentially does it take a negative value? And we can do that by using the notional index value here. So 25 is our call to memcpy. As you can see, if we call that, we get that back, and then we can say, hey, I want to get the parameters, but I want third parameter. So we're calling the third parameter, and then we're saying, I'd like the definition site for that, and also I'd like the use site. So we're seeing, where is it defined and where is it used, which is great, because if we can control the argument that comes in, we potentially have a vulnerability that we can exploit. And just to double check, we can look at these, possible value ranges within that third parameter memcpy, and it in fact does take a rather large number. So that could potentially be a underflow or overflow situation, depending on how we play this. Continuing, we can also look at the def use, so the definition used for the phi nodes as well. So we can assign SSA. We can go to the 17th index, and then we can call that, and it returns that particular instruction that we're interested in, and then we can again call the definition and use. So that's manual. That's just one instruction. So we might want to apply a bit of automation to this and get some more details back. And in this next cell, that's exactly what we're doing. So if we go through and run this, it will give us the results in a pandas data frame, so we can then use that to search the results, because as you can see, the results are a little busy. There's a fair bit going on. So what we want to do is use the search functionality. But before we do that, we need to make sure our types are correct in our pandas data frame, because types can be a right pain in the what. So we'll make sure that the definitions are treated as strings and the uses are treated as strings, and then we can search the uses and the definitions for the 17th index, and also the particular third parameter, so the R2_1, and we get that information back. So that's great. But we can also do this in the GUI. So if you don't have the commercial version of Binary Ninja, you've got the personal version. We can use the Python console and the API within Binary Ninja to process. If we scooch over to our to the GUI and work the correct function, we can just take our check for the possible value ranges in that third parameter to memcpy, and it indeed returns the same result. The GUI isn't doing anything different from the headless API. It's using the API in the same fashion, but obviously this current _mlil is a helper function that we've got to help us do the same thing that we were doing in the Jupyter notebook, and we could do that headlessly in our editor IDE of choice. So that's a we've got options. And then just to confirm that we're not doing anything different, if we we look at our 17th index example, we'll obviously assign that as we did before, and then we can call the definition and call the uses as well, and there we go. So that's great. So we can do that headlessly. We can do it in the GUI. But you might be asking yourself, well, that's all very well and good, but why would I use? What's the benefit of using the ILs in Binary Ninja and using the SSA form? What does that give me that I wouldn't get otherwise? So just to show you that in the GUI, it's basically doing all of this for essentially we get all of this functionality for free in the GUI. It's doing the backwards and forwards slicing for us. So if we go to that 17th index version and click on it here, we can see it's highlighting it's highlighting all the instances where it's defined and used, and the the memcpy example is the same as well. So that's nice that we've got that. But back to the question, why would we use this? Well, using the IL gives us the ability to take assembly, lift that to an intermediate language, intermediate representation. Use terms interchangeably if you like, and we can model, say, vulnerable functions, behaviors that we're looking for, using Binary Ninja scripting and the API and the ILs, and basically scan over, bulk binaries and different architectures with different instruction sets without having to worry about the particular nuance between those different architectures and instruction sets. So that allows us to take a much broader view without being specific to a particular architecture. I'm not saying you shouldn't know those architectures, because when the tools fail, and they will fail, you'll have to troubleshoot yourself. So having that knowledge, or knowing where to look to troubleshoot is a good thing to have. So that's it for now. And in a future video, we might look at how you actually model that behavior. So maybe the memcpy example, how we would do that in bulk against different architectures, and then or maybe looking at graph theory and dominance frontiers, because we didn't touch on that, but it is useful to know. So that's all for now, and thank you very much.